Hi, this footage was filmed in mid-December 2025, and it shows me preparing for the lab course that I held in January 2026. Now it's February and I'm editing and making this video for you because I was planning before the lab course to take footage and take you with me and share a little bit the steps, the preparation of the lectures, the preparation of the course, the didactic thoughts behind, and what helps me to prepare this course, execute this course, and still commit to my science job. On that day, I scheduled for myself to prepare all of the buffers and solutions. And number one of not interfering with the job, the science job, is having a plan. Like always in life, it's good to have a plan. At this stage where you see me now labeling here the bottles before I add components of the media, the growth media for the yeast strains, at this point I am merely executing the tasks that I set for myself. And I'm not overthinking, I'm not testing, I'm not asking how many bottles. I have a plan, I have a list. It's called Experimental Section for Lab Supervisors, and it's a Word document that I established when I planned the course. Everything is in there. How many bottles of what, empty, filled, conditions, when to prepare it, what to do. And that is how I can manage. So just as a little bit of background, what is this course all about? This is a lab course, which is the core component of a honed module at a German university. And the course is set up to have a preparation phase. The students read literature by themselves. They are guided to prepare a presentation. And we meet for a core of 2 weeks in a lab course where we execute experiments. And then after this meeting phase, there is again a phase of reflection, and students write a lab report on their own where they get feedback and the option to revise if necessary. This is a rather small course with a maximum of 12 participants to work out as didactically planned. So you can also imagine that the preparation for 12 students that work in groups of 2 is not huge. I can easily manage alone to prepare that. But just to let you know, I also prepared and coordinated with the help of others other courses that contained more than 150 students. They were split in different groups over a whole week. We repeated the course several times to manage. But so just for context, this is a rather small course, but the preparation for either course with a small number of students or a large number of students, it follows the same routines. And first of all, have a plan. So what you see me do here is put together the growth medium for yeast. It needs to be autoclaved for sterility. And this is a stock solution. It's a 2.x times stock solution of medium that the students then have to dilute with water, and you have to add the carbon source, so the sugar that the yeast will feed on. And this is really like we also work in the lab, and it's not just to replicate how the lab work works, it has also a didactic background, because the students will learn how to dilute concentrates into their 1x working solution. And now it sounds really simple to dilute something that is 2.5x into a 1x solution. And it is, but like with everything in life, you have to do it once to know how it works and to be certain about what you're doing. So we used the chance to give students stock solutions and dilute them, add components to learn this lab technique. And very importantly at this point, I want to say that we do not just let the students go into the lab and then say, well, now make the medium. No, we talk about that in detail, no matter how simple it might sound to you, to mix a sugar stock solution, water, and this medium stock solution to end up with a growth medium. We do the calculation separate and then in the plenum on the whiteboard. This helps immensely to start simple, but share these simple measurements and calculations. And that will also then make the students confident in the lab. So the moment they hit the lab and they take the bottles in their hands, they know already what the volumes are that they are supposed to mix because they calculated it before. And I can only recommend to any educator to take the time in courses to make sure that this simple step that comes natural for us who work in the lab for many years, to take time and let the students actively calculate, learn that, understand what is molarity, understand what is X, so concentrates, understand what is percentage, weight, volume. It is something that many people would say, well, this is simple math, they should know it. Yeah, it's simple math, and you have to do it once to know it. So if you notice that there is a bit of a lack of competence in that respect because it was just not applied before and practiced before, take a time for that. 30 minutes, have a classroom, which is a safe space to make mistakes and to understand really how to do it. Understand what happens when you dilute different stock solutions that go into one main bottle, how to know how much of what and how much water. And more importantly, you can do this intuitively and just divide basically and fill up with water. But there's also a mathematical way to get there, and there are different ways of how you reach the same conclusion. And there is no better or worse. There's just different learning types. Some students do it more intuitively, some students need it on the piece of paper to be confident. So the medium is made, and you see the autoclaving tape that will show us after it's coming out of the autoclave, it will be dark color, so it will show us that it's a sterile solution. Also there, if students have never seen this before in their basic studies, one or two may ask, why does this have dark stripes? It's not something that you learn in kindergarten. So let them in on all of these things. Apart from having a plan, it's important not to leave anything to the last minute. I prepared this in December, well knowing that there is still a few weeks between now and the start of the lab course. And even when the lab course starts, there is a bit of a backup time that we could use to prepare if something failed, basically. But it's better not to leave it to the last minute and have a plan weeks before. Decide what can be prepared and stored, what is sterile, what remains to be done freshly because of expiry date or decay, and then include this in your preparation plan. Now, what am I doing at this point is I'm not diluting actually, that's the point. So I am making aliquots of oligonucleotides, which are primers for a PCR. The white cap tubes, they contain 100 micromolar stock solution of oligonucleotides that we use for PCR. And the Eppendorf tubes will contain the same 100 micromolar. For the PCR reaction, the students will need to dilute this 1 to 10 because we work with a 10 micromolar solution. And again, it seems simple, just dilute 1 to 10. This is a learning step that is very important. Do I do it before? Can I dilute it in the final mix? Do I do a master mix? This course that I teach is prepared so that it is designed to be student-centered and learning-centered. What this means is that there is no rule how you pipette the PCR. I and my assistant, we will let them know the options and we discuss options, making a master mix, adding this and that, diluting the primers before, diluting it in the master mix. in the end, the result counts, and the knowledge of that there are different ways of how you could do it. Is there a preference that I have as a more experienced lab worker? Sure. And I also let them in on that if there is a practical reason, basically. And this leads to a learning experience for the students where not only the PCR is working in the end, because what needs to be in the tube ends up in the tube in the correct concentration. The additional benefit of such a strategy in a lab course is that they learn that there is not the one hook way to do it, and that they have to start thinking, and that they are allowed to start thinking themselves, what is the order of steps that I will do? Is what others show me based on a technical reason? Is it based on just habit? And this will help in case they have to ever establish a protocol or modify a protocol, to know what is important to stick to and what is possibly a way to change, adapt, modify the protocol. I could also give them the stock solutions directly from the white cap tubes. That could lead to contamination if students mix up things, but in my experience, this is a slim chance. It can happen, but it's slim. No, but why am I giving them aliquots for themselves is time reasons. If they go to the freezer, they pick out their own aliquots and they don't have to share with the other group members. So it is very pleasing to prepare those things, and I have my trusty little checklist, and a box is ready to be loaded with the boxes. You see already here there is a color code. Everything in the lab is color coded. This makes sense for the 6 groups. We have 6 colors. We happen to have those colorful racks in the lab, and yeah, I use the color coding as a way to organize myself, because every year different names will appear, different student groups will be there, and the genes of interests remain the same, the groups remain the same, and it's easier for me to label all the data and to have a clean documentation and storage of data that the students produce by just using the group colors: pink, blue, white, orange, green, yellow, and now I forgot the last one. White, green, orange, yellow, blue, and pink. Yes. This is nothing that I recommend or that is necessary. It just happened to be very handy in this specific case. So what I recommend is figure out a group naming strategy so that when you will in the course upload results, data, images, and so on to the learning management system or to whatever platform you share, you have easier time to label it. And yeah, colors are one way, numbering would be also another way, just to number the group to 6. So what we also have to prepare is backups. For a student-centered learning, it is important to also let them do things. So we supervise and we are always there, also for safety reasons, obviously, but it's not like we control every step. That's what the team is for. They work in teams for a reason, and there's a certain control aspect behind that one group member can tell the other group member, hey, don't mix that, or you took too much, and so on. Nevertheless, sometimes it can happen that there is a mistake, and the mistake is observed, and then they say, oh, I mixed the wrong amount, we have more stock solution. And that's why it's good to have a little bit of a backup. So some more of the medium, some more of the stock solutions, just in case. And then it's very convenient to assure them that this is exactly what this is all about. Learning how to work in a lab, observing, realizing a mistake was done, then notifying and making it fresh from scratch. This is good laboratory practice. And that's why having a little backup is a good plan. In general, that is my motto. The lab course is a safe space. It is not about doing everything right and never making a mistake. We try to do everything right, but the important part is to learn from the mistakes. And that requires an atmosphere where it's allowed and not connected to fear, to let the supervisors in on the fact that there was a mistake. I have very good experience using this as a whole culture in the lab, basically. So it is really close to a real lab. You have stock solutions at hand, you have to dilute, you're responsible yourself for what ends up in the reaction. Nevertheless, if something goes wrong, which you should notice yourself, but in a course, you have the advantage you're two people, so you always have an observer when you do things. Then when something goes wrong, it's not the end of the world, there is a little bit of a backup. And also there can be backups for example, failed PCR reactions. It is not a bad thing to have a PCR fragment in the freezer to hand over to the student so that they continue with the transformation. Or if the course is designed in a way that there is really enough made, they can also share from another group. And importantly, in our course, we learn then also how to document this in the lab book. A successful lab course and teaching unit starts with the preparation and the didactic thoughts behind. I hope this was helpful. I was at this moment very happy. I have fun preparing these things and closing the box, waiting for January. At that point, I was looking forward to a Christmas break with my family. And I knew when I arrive here on the Sunday before the course starts, I have easy time setting up the lab. Happy teaching to all of you, and see you in the next video.